Okay, we're going to talk about complex numbers today. And first of all, we need to understand what the complex number is. It's an imaginary number. So we're going to represent it with I. And the definition of I is that it's representing the square root of -1. Okay, because that does not exist. So we're stating that the square root of 1 is an imaginary number. Okay, so if I do I squared, do you understand that that would be the square root of -1 squared, which ends up canceling, and that ends up being -1. Or if I do I cubed, okay, that would be -1 because of the I squared times another I. So -I. Okay, so that's important to know. I is the square root of -1. I squared equals -1. And I cubed is equal to -I. Okay, and it all derives off of I being equal to the square root of -1. Okay, so some basics. So that's the imaginary number. Complex numbers will involve both. Okay, so if we were to simplify this, it's just the same polynomial operations adding like terms. So we can put the 16 minus 5 together to be 11, and then the I parts together to be plus 9I. And we usually write it with the number first and the imaginary part second. Okay, what if I have some kind of brackets in there? Don't forget when you have parentheses that you have to distribute. So without parentheses, this would read 9 plus 4I plus 4 plus 5I. So now I collect 13 and then plus 9I. Okay, 6I squared. So now we've already learned the value of I squared is -1. So now this becomes 6 times -1 or -6. Okay, 2I and then times 5I plus 7. Okay, so this is a parentheses, so we're going to distribute. So this becomes 10I squared plus 14I. Okay, and I squared is -1. So in the end, this is -10 plus 14I. What if I have a binomial squared like that? Okay, we can't forget that really this looks like expanded like that. So now I'm going to do a whole FOIL system. First times first, 4I squared, outsides minus 6I, insides minus 6I, and the last is plus 9. Okay, and this is -4. And then I group those together, minus 12I, plus 9, and now I can put -4 and 9 together to read 5 minus 12I. Okay, next example would be a fraction. So 3 plus I over 2 minus 4I. Okay, so we're going to learn how to rationalize. We did this in grade 11 when you did not want the variable in the bottom, okay, the denominator. So I'm going to multiply. Remember, the word was the conjugate. So the conjugate of this binomial is 2 plus 4i. Okay, but if you do that to the bottom, you have to also do that to the top, because essentially you're multiplying by a value of 1, right? Because same thing over same thing is a value of 1, and when you multiply by 1, you don't change the value of anything. Okay, so now we FOIL. So 6 plus 12i plus 2i plus 4i squared. Okay, and then on the bottom, we understand with conjugates that the outsides and insides will always cancel. So when we do conjugates, we do the FLA instead of FOIL. So this becomes 4 minus 16i squared. Okay. So this, and then this is a minus 4, right? Because of the I squared, becomes a 2. And 12 plus 2 together make 14i. And then this becomes the opposite because I squared negates it. So 20. I guess if you really want there, you can simplify by dividing everything by 2, but okay, next, simplifying exponentials, forms of I, so I to the 80. So how many I squareds can you take out? So if I rewrite this as I squared to the, and this would become 40. Okay, do you see how that rule still represents that's I to the 80? And now it's like saying negative 1 to the 40. So that ends up being a positive 1. Okay, let's try another one. I to the 19th. Okay, so when I rewrite this, I have an I squared, and then the most I can get to is an 18. So 2 times 9 is 18, and then I would still have another I after that. Okay, so 18, and then this is the 19th I. So now this is a negative 1 to the 9th times an I. This ends up being a negative 1, so negative I. I to the 21, so I squared, so the most I can get to is 20 because of the odd number, so I'm going to put a 10 there, and then another I, so there's my 21, negative 1 to the 10th times an I, so negative 1 to the 10th is positive 1, so that turns out to be I. Okay. Let's see here, another example. Negative I to the 15th. Simplify this one. Okay, so another way to write negative I, if we recall, was I cubed. Does that make sense? Remember that from the start? And so now this is going to turn into a 45 as an exponent. And now I'm going to go back to my other strategy. I squared, and I can go to the 22 to get 44, and one more to get my 45. So this is negative 1 to the 22 times an I, so this is a positive 1, so that ends up being simplifying to just an I. Okay, let's check out this example. 2i in brackets cubed times negative I to the 9th. Okay, so this would become 8I cubed, right? Because you have to also cube the 2. And then I'm actually going to rewrite this as I cubed to the 9th, because negative I can be replaced with I cubed. So that equals 8I cubed I27, which will become I to the 30th. Now let's break down how many I squareds we can take out. And so now this is negative 1 to the 15th, which is negative 1. So my answer is negative 8.